if you remember when we graph a function, let's say I'm going to say that this is 10 to the x, and then I'm going to graph the line that bisects y equals x. This line divides the plane into two equal parts, this part and this part. Why is it used? Why is it important? Because this function is, first of all, it's a function, but by the horizontal line test, it's called 1-to-1. 1-to-1. What does it mean? It means that even for each y value, I only have one x value. Only functions that are 1-to-1 have inverse functions. So this is 1-to-1 by the horizontal line test. Its inverse function will be a mirror image with respect to this line. So I have to copy this function here. It will have to be a mirror image with respect to y equals x. That is the graph of its inverse function. So how do I graph it? This function, as you see, is not friendly. It's not defined here. It's only defined here because this is a vertical asymptote. It doesn't touch it. When x approaches 0 from the right, what is the tendency of this function? Can anyone tell us that? As x approaches 0 from the right, the tendency of the function is to do what? Exactly. Exactly. What is this red function? Is common log x. Notice that it has to have the same base. I didn't write the base. It's implied. We know it's there. So this is the common exponential. This is the common log. It's inverse. It's inverse function. So again to the calculator. 1 second, please. Here. So see this key, the LOG key, it doesn't have a base because it's base 10. And it shares the same key with its inverse. The second log gives us the inverse, the exponential. The log gives us just the regular key, gives us the log. If you try to put 0 in here, the calculator will scream loudly because you can't. It's a vertical asymptote. If you want to put log and put in -3, it will scream again. Why? I'll press in a moment. Why will scream again? Because -3 is here, and this function does not go to the left-hand side of 0. So if I want to plug in -3, the calculator will scream again at me, and rightfully so, because this function doesn't exist to the left of 0. So log is not a friendly function. We have to be careful with it. It's like the square root, which does not exist on negative numbers. It's like the rational function that cannot have 0 in the denominator. And this is, I promise, the last function with issues. So log, rational, and the square root with an even. These are problems. Functions that may not have or may not be defined everywhere. They may not be defined everywhere. Functions with problems, these 3. Not exponential. Exponential is nice. No issues at all. I don't ever have to think about it. Like with a radical with an odd index. I don't have to think about it, ever. Like polynomials, I don't have to think about them, ever. Okay, so this is the case in which the base is greater than 1. And this has to be the same base. If this is base 2, this has to be base 2. If this is base 5, this has to be base 5. Otherwise, they will not be inverses of each other. But what happens to the other shape? This one. This one, let's say, is 1/2 to power x. Well, I cannot draw the graph before I draw I cannot draw the graph of the inverse before I draw y equals x. And now it's a different situation. See, here, this function does not cross this line. But here, this function crosses this line. Well, that point cannot be moved anywhere. It has to belong to both functions. Okay, so here it is. This is log base 1/2 of x. And the same thing has to happen. The two functions have to overlap. This piece is this, and this piece is this. If they don't overlap, they are not inverses of each other. But they are inverses of each other. Notice that they are both decreasing. Here they're both increasing. Okay, so I want to review the properties of the log, and a very important property, how we go back and forth. So let me make sure I have them in the correct order. And I am on page 5. So very important properties. The properties that I'm listing here are properties of the log, for log functions, all of them, regardless of the base. Log applied to a product is the sum of logs. This is from your past experience with algebra. Back and forth. If I have a sum of 2 logs, I can clearly write this. This is not log of A times log of B. No. This is log applied to a product, which is the sum of the log of A plus log of B. This is the product rule. The quotient rule is identical, but it has minus in between. So log of A over log of B. And you can go back and forth. Log of A over B, this is in parentheses. It's not log of A over log of B. No, it's log of A minus log of B. Back and forth. And the last one is log of A applied to A to a power. That becomes a factor in front. So when we talk about the factor, we mean multiplication. And again, back and forth. So this is the product rule. This is the quotient. And this is the power. The power goes in front as a factor, multiplication. We also have a change of base formula. So if I have, let's say, log base 3 of 10, this can be rewritten log at the top. Which logs I will use? I will use the ones that I have in the calculator. Although I'll show you that now the calculators are so sophisticated that they allow us to put in the base we want In the past, that was not possible. But the formula says if I want to change into log 10, I have log 10 applied to the number over log 10 applied to the base. I can apply natural log because natural log is also, I didn't say that. So if this function is e to the x, if that function is e to the x, then this function is ln x. So this is wonderful. I went to the other page. Okay, so this is natural log. You'll say, well, why don't we use natural log? Why do we use ln? Because it's coming from German. So it's log natural instead of natural log. So that's what we see, and it has a special key. Let's look at the special key. It's right here. It's the next one. It's not the log, both of them have base 10, but it's ln, natural log, e to the x. So just activate natural log, and you need to remember that the base is e. How do I remember? Well, all I have to look at is this key, okay, right here. So if I apply natural log to e to the x, I'm just curious to see. I'm petrified of what the answer would be. Okay, so the answer here should be x, but it cannot give us x. Who knows what? Oh, gee. Okay, sorry. This is the very first time I did this with my students, so it makes no sense. The 5 makes no sense. So the answer has to be e. The answer has to be x, because natural log cancels e, and e cancels natural log, but it gave us 5. That's really silly. Okay, so this is the natural exponential function, and this is the natural log function. Okay, so we can use the same thing, natural log of the number over natural log of the previous base. Again, this is a little bit redundant now. Let me show you why. Because the calculators are so sophisticated that there is a key here under math. Let me look for it because I never use it. Here it is. Okay, I never use this because I use the change of base. So it's log in any base we want. But I think we have to put the base first. So 3, and then math, and log base. And not all calculators have it. Okay, I was wrong. Okay, good. So base 3 of 10. Base 3 of 10. That's what we have. And this is the same thing with what I just showed you. Meaning, what did I show you? I said log of 10 divided by log of 3 is the same thing with what you see at the top. They have to be the same. And the same thing with natural log of 10 divided by natural log of 3. Okay? Same thing. It has to be the same thing. So you have either the option of log over log, common log, or the option of natural log over natural log, or you have the shortcut in math to determine any log you want in any base you want. Okay. So again, this is a little bit redundant because the calculator allows this, but I never use it myself. I use these. Okay, now, but it's up to you. You are allowed to use anything you want. Okay, any option. Now, the most important correspondence here is any exponential equation can be replaced by a log equation, and vice versa. And the question is, who cares? Why would I ever be interested in this concept? What is it used for? Well, if I have log base a of x, let's say it's a number, this is a log equation. I have a log base whatever number, I have x, and I have a number. This is a log equation. But this can, I will, most of the time, or many times, I will not be able to solve it. But if I change it into an exponential equation, I will be. So how do I change this log equation into an exponential equation, and vice versa? Counterclockwise, starting with the base. The base raised to y equals x. The base raised to y equals x. Now this is an exponential equation. Any exponential equation can be replaced by a log equation. Any log equation can be replaced by an exponential. Why is this useful? Because if I want to solve logarithmic equations, I may have to change them into exponential to solve them, and vice versa. If you give me an exponential equation, I may not be able to solve it till I change it into a log equation. That's why this is super important. I'm going to go and say that this is the most important item in this section. Okay, so this, now I'm going to open on page 203. And let's practice what we just talked about. Okay, I would like to we're going to come back to this problem, but first of all, so I will not forget about this section of 9 to 16. Use a calculator to find each log. So if I want to find, let's say, 21, natural log of 0.52, 0.052, all I have to do is just put natural log 0.52, and that's it, and I'm done. It's negative 2.96. Okay, good. Now solve. I want to work on these problems and then on these problems to find the domain, because the domain is a problem for logarithmic functions, as I mentioned, like with the square root, like with rational functions. This is a major issue here, like with the other two. Okay, so I like to choose a problem and then you choose the next one. I like to choose 45. So in 45, we have e to negative 0.02t equals 0.06. If you ask me, what are you going to raise e to get 0.06, even if my life would depend on it, I will never know. No clue. None whatsoever. But this is an exponential equation. I can change it into a log. If I change it into a log, I will be able to solve it. So what we are going to do, we're going to, because this is the base e, we're going to apply natural log to both sides. It's like squaring both sides. It's like taking the square root from both sides. So one of the properties that we listed a few minutes ago is when we apply log to a quantity that has a power. I'm applying log to a quantity that has a power. The power goes in front as a factor. So I have negative 0.02t multiplied by natural log e equals natural log 0.06. It's done. Because now I can solve for t, dividing both sides, natural log of 0.06. Don't get thrown off by this number. It's just a number. It's natural log of something. It's just a poor number. Divided by negative 0.02 times natural log e. Now, I would like you to remember one rule. I'll come back to this in a moment. I would like you to remember a very important property. Log in any base of the base is 1. What is the base of natural log? Can anyone refresh our memory? What is the base of the natural log? What do I put here? Look at the key. Yes?
10.
That will be log. Log is base 10, but natural log is base?
So base e.
Exactly. We don't write it. So this has to be 1. Log base e of e is 1. Log base 10 of 10 is 1. Log base 1/2 of 1/2 is 1. So this will be 1. There is no need to put it in the calculator. You can, it's no mistake. So I determine t, but I have to plug it in. And be very careful how you plug it in. Careful, careful, careful. So I have natural log of 0.06 in the numerator. I divide by, and you must put parentheses, depending on your calculator, to be on the safe side, please put parentheses, negative 0.02. There is no point in putting natural log in there, because natural log e, I meant. There is no point in putting natural log e in there because it's 1, because of the property. And this is it. So assuming they want us to round up to 2 decimal digits, I will say t is approximately 140.67. Is it true? I have no clue. I have no idea, but here's what I'm going to do. Second e, in parentheses, I will put negative 0.02 multiplied by the entire previous answer. I don't want to round it up. You could enter 140.67. I don't want to, because the answer is right here. Exactly the previous, because if you have some other calculations in between, don't do this. I have it previously, right here. And when I press enter, if I do not get 0.06, if when I press enter I do not get 0.06, then this is incorrect. So here it is. Press enter. That's it. So I checked my answer. Good.